An ant is pretty stupid. It doesn't have much of a brain, no will, no plan. And yet, many ants together are smart. An ant colony can construct complex structures. Some colonies keep farms of fungi, others take care of cattle. They can wage war or defend themselves. How is this possible? How can a bunch of stupid things do smart things together? This phenomenon is called emergence, and it's one of the most fascinating and mysterious features of our universe. In a nutshell, it describes small things forming bigger things that have different properties than the sum of their parts. Emergence is complexity arising from simplicity, and emergence is everywhere. Water has vastly different properties to the molecules that make it up, like the concept of wetness. Take wet fabric. If you zoom in far enough, there is no wetness, there are just molecules sitting in the spaces between the atoms of the cloth. Wetness is an emerging property of water, something new only created by a lot of individual interactions between water molecules. And this is sort of it. Many things interact under a certain set of rules, creating something above and beyond themselves. It turns out that more is different. This different property is itself a new thing, and that new thing can couple with other new things to repeat the process. You can imagine this as layers stacked upon each other, every layer made from more complex parts. Atoms form molecules, molecules form proteins, proteins make up cells. Cells make up organs. Organs form individuals. Individuals form societies. But how can something be more than the sum of its parts? How do ants form the sort of cloudy entity that is a colony? By following a rule set that produces order through chaos. For example, let's look at how an ant colony distributes jobs. Let's assume that a colony should have 25% workers, 25% caretakers, 25% soldiers, and 25% gatherers. Ants communicate their current job via chemicals. For example, a worker ant constantly secretes chemicals that say, "I'm a worker." When ants meet other ants, they smell each other to gather information, telling each other their job and what they're doing. Both keep track of who they met in the past. Now, imagine an anteater kills most of the gatherers. If this isn't fixed quickly, the colony will starve. Many worker ants need to switch jobs, but how do you tell this to thousands of them? Simple, you don't. Our worker ant will still meet and smell other ants, but it will encounter almost no gatherers at all. It counts too few gatherers until it reaches a critical point, and then it changes its job. The worker becomes a gatherer. Other ants will do the same until after a while there are enough gatherers again. The balance is restored all by itself. The actions and interactions of an individual are random. You can't plan which ant will encounter which other ant, but the simple set of rules is so elegant that a colony's many operations emerge as a consequence. On an even more fundamental level, hundreds of millions of complicated molecules interact to maintain a robust and amazing structure. A being with vastly different properties than the sum of its dead parts emerges. The smallest unit of life, a cell. We still don't have a clear definition of what living things are, we just know they emerge from things that are not alive. Cells combine and cooperate, they specialize and respond to one another, and over time, we develop into complex organisms with remarkable capacities. Your arms and legs and heart are an incredibly complex and complicated system made of trillions of individual stupid things, and yet we breathe, digest, and watch YouTube videos. How do your cells know what to do? Think of the pacemaker cells in your heart. Billions of them need to send out an impulse just at the right moment to collectively create a heartbeat. Our cells exchange chemical information with their neighbor cells to see what they're up to and then decide what to do. If it's among a lot of cells that are working on the same task, it will start working on that task as well and sync up with them. There is no mastermind giving commands, just single units communicating with their neighbors and acting according to the feedback they get. What about our most important part? What is the thing that asks these kinds of questions? Is our consciousness then an emergent property of the cells in our brain? This question is too big and important. It deserves a video of its own. Some things that emerge are hard to define. You can't touch an ant colony, only its parts. It has neither brain, nor face, nor body. And yet the colony interacts with the world. Just like colonies emerge from ants, things emerge from humans, like nations. What actually is a nation? Is it its population? Is it its institutions? Its symbols like its flag, colors, or anthems? The physical things it makes like cities? The territory it occupies? All of these things are fluid. Populations change and are replaced. Institutions come and go, cities can be constructed and abandoned. Borders have changed all the time for most of history. And symbols get replaced by new symbols. A nation has no face, no brain, no body. Are nations not real then? Of course they are. Just like ant colonies, nations interact with the world. They can change landscapes, wage wars, grow or decline, and they can stop existing. But they only exist because of a lot of humans interacting with each other. But not just nations. All the complex structures that surround us emerge from us. Even if we don't intend to, we are constantly creating communities, companies, cities, societies. All of these things are entities that have fundamentally different properties and abilities than the pretty stupid apes they emerged from. We don't know why any of this happens, we just observe it, and it seems to be a fundamental property of our universe. It may be the most beautiful and wondrous property of our universe.